Morning
Next
students.
topic is importance of species diversity to the ecosystem. Okay. So what they are saying about the diversity of species, many different types of species should be present for the proper functioning of the ecosystem. So some naturalist geographer has put some information regarding the same, shared some information regarding the same, and mostly it was hypothesis. Hypothesis means we are thinking that yes, it can be the reason. Okay. Now, when you are saying this importance of species diversity to the ecosystem, David Tillman has said that more species tend to be more stable than those with less species. So, an ecosystem with more species are more stable than the ecosystem with less species. Okay. Like for example, imagine this is the ecosystem. Okay. Here only 2 species are present. How many species are present? 2. Okay. Then it is not that stable. If it is having 10 species instead of 2, then that ecosystem is more stable. Then that area, that region is more stable. Why it is so? Because these 2 species, because of some whatever drought, famine or flood, water, sometimes they cannot survive. So both the species will be lost. If it is 10 species there, somehow some can survive and functioning of the ecosystem will be taking place properly. So he said that a region or a ecosystem which is having more species is more stable compared to an ecosystem or a community which is having what? A less species. Okay. So that was his observation. Now, attributes or characteristics of a stable community. So, a community is said to be stable if it is having some characteristics or if it is having some attributes. So, what are the attributes? First attribute is that it should not show much variation in productivity from year to year. Like for example, this is a community. Okay, so just imagine this space is a community and here I am cultivating some plants. Okay. So these plants, when you are seeing this here, has given me 100 kgs of yield. Rice plant means I am cultivating rice. It has given 100 kg. How much it has given? 100 kg. Next year, it is giving only 10 kg or 20 kg. Whether it is stable? No. The productivity, when you are seeing, it should remain most probably constant. Constant means that if it is moving means less here and there, like instead of 100 it is 98, 97 kgs or even 90 kgs, then also it's fine. Okay. But the productivity all of a sudden there should not be any fluctuation, wide fluctuation. Okay. So should not show much variation. It should not show much variation in case of what? Productivity. In that case, year after year it is producing correctly somewhat similar figures. In that case it is more stable. Okay. So that is number 1. Number 2, it should be resistant to occasional natural and man-made disturbances. Resistant to means what? It has to have the capacity to resist the things which are getting into. It can be a man-made thing or it can be a natural. Natural, like flood is coming, the plant should have the resistance to withstand flood. The plant should have the resistance to withstand drought. I am introducing some chemicals into it. The plant should have the capacity or the power to withstand that fertilizers or pesticides. Okay. In that case, that community is more stable. Okay. So all the species living over there should be having what? Resistant power. In that case, that community will be more stable. If they are not having resistant power, they are prone to everything. The species, when they are exposed to something not natural, in that case, what will happen is that the species will die, isn't it? So this obviously the species diversity will come down. In that case, that community is not going to be stable. Okay. And next is what? It should be resistant to invasion by alien species. Resistant to invasion by alien species means what? Imagine the Indian varieties are only present. Okay, Indian species are present. Someone from some other place, like for Africa, is coming over here. Okay. Now what will happen after they come from Africa? What is going to happen is that they are going to invade. They are going to come into our area and they are going to occupy our space. In that case, we should be more resistant. Okay, we should be having more power to resist them, so that they are not spreading, increasing their population, thereby decreasing our population. We should be more having more resistant power. The desi variety of plants or animals or any species, they should have what? Resistant to withstand. Okay, even the alien species, if it is coming and starting to grow, we are competing with them and we are winning over them. In that case, that community is more stable. Okay, so alien is someone from outside getting into a population. Okay, yeah. So first one is what? It should not show much variation in productivity. Okay, productivity, how much they are producing should be somewhat constant. Second, it should be resistant to all natural and man-made disasters or any disturbances. Okay. Third is what? It should be resistant to alien species. In that case, my community is more stable. Clear? Now moving on to important topic. The topic is Rivet-Popper hypothesis. What is the topic? Rivet-Popper hypothesis. Listen students, it's a very important topic and a very simple one. Okay. So, Stanford ecologist. So, what is his name? Paul Ehrlich is the ecologist, Stanford ecologist. Okay. From a place Stanford. Now this Paul Ehrlich, when you are seeing, he has put forth an hypothesis called as what? Rivet-Popper hypothesis. Now what do you mean by this Rivet-Popper hypothesis? He used an analogy. Analogy means, you know, comparison. Okay. He is going to compare the ecosystem, functioning of an ecosystem is compared to an aeroplane, working of an aeroplane. Okay. So this aeroplane, when you are seeing, ecosystem, you know, ecosystem, all abiotic as well as the biotic component, the whole setup, we call it as the ecosystem. So ecosystem is equivalent to aeroplane. He said that an ecosystem is equivalent to aeroplane. So this is an aeroplane and this one is an ecosystem. So this ecosystem as well as the aeroplane is similar. Okay. Now listen very carefully. This aeroplane, if you are seeing, it is made up of many rivets. Rivets means what? Like nut, bolt, screw and all, everything will be present now. So the parts, all small parts, spare parts and all are connected and the aeroplane is made, isn't it? So this things, we call it as what? We call it as rivets. In the same way, the ecosystem when you are seeing, it is made up of species. What they are made up of? Species, different types of species. So aeroplane is equivalent to ecosystem. The rivets when you are seeing is equivalent to species. Okay. So aeroplane, rivets, ecosystem, species. Aeroplane is what? Equivalent to ecosystem and rivets is equivalent to species. Now I am going to aeroplane. Okay. So this aeroplane, if you are seeing, passengers are getting in. One day, one passengers moving one rivet, not bolt, something they are removing from the plane. Okay, they are taking it. So what happens in the beginning? No problem. One bolt taken, let it go. Next one has taken something else, let it go. Like that, slowly what happened is that in the beginning there was no disturbances. But gradually when many bolts and nuts and all these rivets are taken back, do you think that a plane will be in danger or not? Yes, it will be in danger. Sometime it will take off for landing, it will crash, isn't it? So why? Because the rivets are already removed. When you are removing one, no problem. When you are removing two, no problem. First it seems that there is no problem. But if the rivets are removed in huge amount, what will happen? The whole aeroplane will collapse. The same way, ecosystem also, if you are saying, ecosystem is made up of rivers, which is called as what? It is called as species. If you are removing one species from that ecosystem in the beginning, okay. Second species, third species, food chain is getting disturbed. Okay. Thereafter, you can find the whole ecosystem is getting disturbed. The whole ecosystem is collapsed. Okay. That whole thing is getting into barren land, is going to get converted into. So that was the thing what Paul Ehrlich said about Rivet-Popper hypothesis. He considered ecosystem as an aeroplane and the species as the rivets. If you remove one species, it may not affect in the beginning, but if you go on removing later, it will lead to much disaster. Okay, so that is what Rivet-Popper hypothesis is stating too. Hope it's clear. Today we discussed about two topics. The first topic was what? The first topic was your species area relationship, and the next topic is importance of species diversity to the ecosystem. Next we are moving on to laws of biodiversity.
Yes, the next topic what we are going to discuss is loss of biodiversity. Okay, so colonization of tropical Pacific islands by humans. So humans started colonizing where? The Pacific Islands. So we are occupying most of the places, and because of which you can find in the Pacific Islands more than 2000 species of native birds have become already extinct. And according to IUCN Red List, red data is containing the name of different endangered. Endangered means what? Who are on the verge of extinction. They will become extinct if it is not taken care. So according to this IUCN Red List 2004 document, what they are telling is that the extinction of already how many species has been extincted? 784 species in the last 500 years you can find have already have become extinct. Okay, so what and all it is including? It is including, you can find 338. Okay, so 338 vertebrates have become extinct, 359 invertebrates have become extinct, and 87 plants have become extinct in the last 500 years. So the rate is going on increasing year after year. Now moving on to some of the examples of recent extinction. Some species which have extinct in the recent years: dodo, quagga, Africa; thylacine, Australia; steller sea cow, Russia; and 3 subspecies of tiger, Bali, Javan and Caspian, have become what? Extinct. So you can find this is dodo, clear. Thereafter it is quagga, become extinct, thylacine became extinct, Javan tiger. Okay, thereafter you can find Balinese tiger. So these are the some of the animals which have become what? They have become extinct. Clear? And in the last 20 years alone, how many species has disappeared? 27 species have disappeared. Okay, so more than 15,500 species worldwide are facing a threat of extinction. Imagine, 15,500 are facing a threat of extinction. They may become extinct in the near future. Okay, presently 12% of all bird species, 23% of all mammal species, 32% of all mammalian species, 31% of all gymnosperm species in the world are at the threat of extinction. So they are all facing danger. So these numbers you have to roughly keep in mind, because they may ask for one words. In that case you should know. Okay, now we are experiencing 6th extinction. 6th extinction means what? Before humans had appeared, before we evolved. Okay, you can find already in the earth, when you are seeing 5 episodes of mass extinction is over. Mass extinction means when all of a sudden you can find the species are becoming extinct because of some natural disaster or whatever it is, in particular area they were living, because of some natural disaster or something like that, it led to the extinction of those species. So that is mass. Mass means in huge amount all of a sudden the extinction is taking place. We call it as what? The mass extinction. Okay, so this mass extinction, when you see, it has already 5 episodes are over before humans came. Now after human came, the 6th extinction has started. We have started our 6th extinction, and you know that humans are only the major one who is responsible for the extinction of the species, because we are disturbing the environment, we are disturbing them in such a way that the climatic condition, everything is changing, because of which the extinction rate has become higher. That's what they are saying in the 6th extinction. How it is different from the rest of the episodes? It is different because the current rate of species extinction, when you are seeing, it is 100 to 1000 times. At places it changes. Okay, so from 100 to 1000 times faster the species are getting extinct than pre-human period. Means before we were there, the 5 episodes slowly only you can find, because of some reason extinction was taking place, not that faster. But after humans had come, it is extinction is taking place at a faster rate. That is the 6th phase of extinction. We call it as 6th extinction, and it is how much time faster? It is 100 to 1000 times faster. So hope it's clear. With this today's topic I conclude. We discussed 3 topics. One is species area relationship, second one is importance of species to ecosystem, and the third one was loss of biodiversity and introductory part. In the next class, we will be discussing about causes of biodiversity loss. Okay, so what are the various reasons, consequences, everything we will be discussing. Hope you all had a nice day. Thank you.